this just for your reminder. Remember, you're adding all sides for perimeter. And then when you get to area, you are doing length times width. Now, the thing that kind of stumps students is they won't put square units. They'll put units squared. And they think something's up here. All that means is that you multiplied, you're in the second dimension, and you multiplied two different dimensions. In other words, 4 is the width and 8 is the length. That's two different dimensions. So don't ever get confused with this, all right? If you want, I don't care if you just ignore it and look at the number, okay? That means that you've multiplied two different dimensions. You're in the second dimension. And that gets really important with Pythagorean and also when we get into doing measurement, okay? So just so you know. So let's flip the page, okay? All right. So each dimension of the new, it says new rectangle is 3 times the size of the original. So now, instead of just doing a figure and making it bigger or smaller, we are doing dimensional change. That means we're taking the perimeter or the area and seeing how we multiply it by a scale factor, what happens, okay? So, a scale factor of 3, all right? And this side is all about perimeter, okay? And perimeter is great because what dimension are you in? You know,
2.
the first dimension. That's why when you write perimeter, you only have units because it's units to the power of 1, which means the first dimension. But we're lazy mathematicians and we leave that off. So perimeter, you're just going around something. That's why it works for triangles, octagons, rectangles, stars. You can, as long as you measure all the sides and add them together, you're good to go. Okay? The same formula works for everything. All right? So, first thing we need to do here is remember we are doing dimensional change. So we're going to look at this perimeter. What is the perimeter here? I've got 3 plus 3 plus 2 plus 2, which gives me 10. I have a scale fact. What is the area? So 3 times 2 is the area. So now I'm in the second degree, okay? So here I've got 3 times 2, which is 6. So here I'm in the second dimension. Here I'm in the first dimension. The sides of the new figure are how many times the original? We learned this yesterday. If I have a side length and I have a scale factor, I would do what to find the new side length? Multiply. Well, now I know that they are 3 times the original because we are multiplying. Okay? The perimeter of the new figure is, so when we're looking at perimeter, since we're in the first dimension, all you're going to do is take that old perimeter and multiply it times your scale factor, and you would get what? 30. Because if I multiplied 3 times 3, I would have 9, correct? 3 times 3 would be 9. 3 times 2 would be 4. Okay, 3 times 2 is...
No, ma'am.
6.
No.
Sorry. 3 times 2 is 6, thank you. And 3 times 2 is 6. Now let's add the new perimeter. I get 6 plus 6, which is...
12.
And 9 plus 9, which is...
18.
And 18 plus 12 is what?
30.
Oh, do you see how it works?
Yeah.
But I can, if I know to do that, just take the old perimeter, which was 10, multiply it times the scale factor, and I have the new perimeter. Now, the difference is this. When you talk about area, okay, we found the area of this figure was 6, didn't we? I said we were in the second dimension, didn't I? So now we're going to have to take, since we're in the second dimension, you're going to do area squared, or the scale factor squared, because you're in the second dimension. So what is the scale factor when you square it? 9, because 3 squared is equal to 9. So it's going to be 9 times larger. Because look at this. If you do 9 times 6, what do you get?
18.
Tell me, 9 times 6.
9 times 6.
54, right? Well, let's look at that. 6 times what equals 54?
9.
Ah. So when you are doing area, you take the old area and multiply it times the scale factor squared to find the new area. And that's what we're going to write down here. Old perimeter times scale factor equals new perimeter. So we'll do this. Old P, which is old perimeter, times scale factor to the power of 1, right? Which is just the scale factor. You don't have to write power of 1, but if it helps you remember that, that's a good thing, is equal to new perimeter. Down here, old or original area times scale factor squared equals the new area. And that's what the only thing you have to remember about dimensional change. Difficult? No. So let's try the one over here. I'm not even going to worry about this right here, all right? Each dimension of the new rectangle is 2.5 times the size of the original. So my scale factor is 2.5 times the original. All right? I'm getting out my little thing, so everybody's going to participate. So, first question. Colin, what is the perimeter of this figure? What's the perimeter of this figure? 11. And how did you get 11? Okay. Colin, don't ask them. Talk to me, okay? So, what's this side, Colin? How much is this side worth, right? Look at what look! Let me talk to him. What is this side? 3. And what is this side?
Oh, wait, yeah, you're right.
What's this side? Okay, so sometimes you need to write those to remember. So what is 3 plus 3 plus 2 plus 2?
I had one more thing, too.
Okay. All right. So we know that. Jenny, what's the area of that figure? 6, because we do 3 times 2, which is 6. Okay. So the sides of the new figure are how many times the original, Elena? The sides of the new figure are how many times the original?
I know this.
What is your, Elena, what's your scale factor? Oh, so they have to be, say it again. What did you just say? 2.5 times larger, because to find the new side length, what did you do yesterday when you needed to find the new side length? You took 3 times 2.5, didn't you? So that means that the sides of the new are 2.5 times the original. So if you take 3 times 2.5, what do we get, Hector? So this would be 7.5 if this is the original and this is the new. Okay? Carson, what is this side going to be? She says 5. How did you get 5? So she did 2 times 3.5, which is correct. So, Amante, what's the perimeter of this new figure? You all should be doing this. Practice during lecture is what will get you to be able to do it on your own. What is it? The perimeter?
25.
25. And how did you get 25?
Because I added them up.
You added them up. Very good. You added all, how many sides were there?
4.
4 sides. So he had to add 4 numbers because there's 4 sides. So that means he added 7.5 for this side and he added 5 for this side. Okay? All right. What is the area of the new rectangle, Braxton?
37.5.
37.5. Okay? Interesting how the area of the original and the area is smaller, but the area of the new is larger than the perimeter. Do you notice that? And it's going to happen every time because when you're talking about dimensional change, you are multiplying times the scale factor squared. What was the scale factor, Logan? So if I take 10 times the scale factor, which was 2.5, what do you get, Logan? 25. Oh, that's how I got the new perimeter. Simon, what's 6 times 2.5 squared? So that's how I got the new area. Do you see that? Okay. So the perimeter of the new figure is how many times the original, Zach? 2. Yeah, you're right. 2.5 times the original. And Fatima, how many times is the new area as compared to the old area? Who knows how to figure that out? Raise your hand. Put all of you, put 2.5 squared and hit enter in your calculator.
6.25.
Oh, so now let's try something. If we take 6 times 6.25 and hit enter, what do you get? So it's the scale, whatever the scale factor is squared, it's that many times larger. Make sense? Okay? No, it doesn't.
No.
Okay. So did you do the 6 times 2.5 squared in your calculator?
Yes, ma'am. I got 37.5.
Okay. So when you did 2.5 squared, what did you get?
2.5 squared. Oh, 6.25.
So if I now take 6 times 6.25, and what do you get? Oh, so 37.5 divided, do you see that it's going to be 6.5 times larger than 6? Because this is your original area times the scale factor squared gave you 37.5. Do you see that? Which is your new area. No?
No, ma'am.
Okay, let's try it a different way. All right? Because if you don't see it, I bet you there's somebody else who's not willing to speak up that doesn't see it. All right. What? All right. So, on this figure, the old area of the original figure, what was it?
I see it now, miss.
What was the original area? 6. So let's just look at area. The original was 6. Okay, new area of a new figure, right? Okay, if you do 7.5, do you agree that 3 times 2.5 is 7.5 for this side?
Yes.
Okay, and do you agree that 2 times 2.5 is this side?
Yes.
Okay, so do you agree that 7.5 times 5 is 37.5?
Yes.
Okay, so this is the new figure, this is the original. This would be prime, this would be the original, right? So 37.5 is how many times larger than 6 is the question, right? Do you agree? Okay, so let's do something. Let's take 37.5 and divide it by 6. 6.25 is what you got, right? And we agreed that 625 was 2.5 squared equaled 6.25, didn't we? So that means that 37.5 is 6.25 times larger than 6.
Oh my gosh, it's just the wording.
It's just the wording. In other words, the new area is the scale factor squared larger. Does that help at all?
Yes.
A little bit.
But I can get there.
All right, let's try one more and see if we can get there, okay? All right, each dimension of the new rectangle is 4 times the size of the original. So what's my scale factor, Braylon? 4. Scale factor of 4. Okay? So we're dealing with a scale factor of 4, people. This is my original figure. So I'm going to put an O here for original. Okay? As soon as I can get a pencil working. All right. So, what's my perimeter, Denise, of my original figure? 10. And she added all 4 sides, I'm assuming, to get that, right? All right. What is the area of the original Andrea? 6, because she did 3 times 2, which is 6. Okay? So my scale factor is 4. So what is the length of my new figure, Kaylee? 40. The length of my new figure? 12, because 4 times 3 gives us 12. So that's the new length. What is the new width, Chris Morales?
8.
Because 2 times 4 is 8. Okay? So, I can do this 2 different ways. I can either, but if I want to know perimeter, the new perimeter, the old perimeter times my what is going to give me the new perimeter, Jamarcus.
40.
My old perimeter times what is going to give me times what? 4, which is my scale factor, right? Is going to give me my new perimeter, which is 40, he says. So, what is my new area, Jasmine? If I know only that my area is 6, what do I take that times to get my new area? No. New area, I'm going to take that times my scale factor squared. So 4 squared, which equals 96.
Did you say 36? 96.
Okay? Now, if I can go back and prove that to you by doing 12 times 8, which is what? 96.
Yeah.
Okay? All right? So you just take the old area, because sometimes they're not going to give you all this. They're just going to say the area of a figure is 6. What is the new area after being, a dimensional change, which is 2.5 times larger, or the area of the new figure is 4 times larger than the original. The original is 6. What is the new area? You just have to take that 6, multiply it by whatever they give you as times larger squared, and you get your answer. Okay? So the sides of the new figure are how many times the original? Tazira? 4. The perimeter of the new figure, A blue, is how many times the original? 4. And the area of the new figure is how many times larger, Chris Benton? 16, which is 4 squared, which is equal to 16 times larger. Okay? All right? Kind of getting it? Oh, God. Why? This is easy. Perimeter. First dimension, scale factor to the power of 1. Area. Second dimension, scale factor to the power of 2. All there is to it. The perimeter is 9 plus 9 plus 6 plus 6, 18 plus 12 of the new figure. Is that the original? No. Oh, did I? It's 3 times the original. Alright, I'm going to get you started. The front side is all about perimeter. So, when I have an original figure and a new figure, my original perimeter is going to be what? I got to go backwards here. Andrea. What's my original perimeter? She says 18. Everybody concur?
Yes, ma'am.
And that's just units. That's not units squared, okay? Maybe if you write just u here instead of and then on the other side we'll do u squared. All right, so the scale factor that was used. Okay, how could you figure that out, Carlos? How can you figure out scale factor with these 2 figures you've been given? What formula did we use? Just say N over O. So what is your N, Carlos? 12. What is your O, the corresponding side? 6. Simplify 12 divided by 6, and what do we get? So our scale factor is 2. So, Chris B, my process step is going to be to find the new perimeter. What am I going to do? What did that rule say right down here? What does OP stand for? Old perimeter. Come on. So what is my old perimeter, Kaylee? And I'm going to multiply that times my scale factor, Amante.
Oh, 18 times 12, right?
What's
18
12?
times
2. And what is my new perimeter, Chris M? 36. Okay, that's how you fill this out. Okay, let's look at the other side. Okay, this time we're talking about area. So, what is the area of my original, Carlos? On the back. What's the area of my original figure? 18 units squared, because I'm in the second dimension. Very important key here. Hector, what's my scale factor and how am I going to find it?
Just say no.
Just say no. And what am I going to use?
Your original area. Oh, we talking about numbers?
Scale factor. How do I find my scale factor?
You put 12 on top.
12 on top.
And you have 6.
Okay. And then what am I going to get when I simplify that? 2. So my scale factor is 2. What am I going to do to find my new area, A Blue? No, we're talking about area,
Oh, old area times scale factor
which is
square.
2 squared.
Yeah.
Because I'm in the second dimension, and what do I get?
Gotta go for it.
What?
72.
Oh, okay.
Because you didn't square your scale factor, sir. You gotta square your scale factor. All right, let's see how much you can get done. Let's go. Get to work.
Why is it